Hey everyone, here's another example from section 3.1. Again, we're converting from standard form into vertex form. This time we've got fractional leading coefficient. This is really not going to be anything different. I think that this problem is a little harder just because of the fractions, but same process. So the first thing I'm going to do is I'm going to factor out 1/3 from each term. So that will be f of x equals 1/3. X squared is still left because when I factor out 1/3, there's still 1 left, so x squared. If I factor out 1/3 of x, that's going to actually leave 3. So basically what I do is I write the number here that's the inverse of the 1/3. Well, what's the number that's going to be left? Well, that's going to be 3x, because when I take 1/3 times 3, it still gives me 1. If I take 1/3 of 3, that's going to be 1 here. And so now I've factored this out, and I've got this in a form that I can now complete the square with. If I distribute the 1/3, that just proves that this equation is really the same as this equation. So I want you to just go through in your head, distribute the 1/3, make sure that you understand that this equation and this equation are the same thing. After that, then, we're going to find b over 2. We're going to square it, which b is 3. So I'm going to take 3 over 2 and square it. Which then that's going to be basically 1.5, but I don't want to write that way. I just want to square what I've got there, which is 9 over 4. Okay, so I'm going to use a fraction instead of using the decimal there, because it's going to make this problem a little easier. So 9 over 4 is what I'm going to add in here, and that'll give f of x, and I'm going to leave a space here. Remember from the previous video, I'm going to leave a space because there's something happens in here. So that's going to give 1/3 x squared plus 3x plus 9 over 4 plus 1. So if you notice here, then I've put 9 over 4, I've added it inside the parentheses. Remember from the previous video, when I added inside the parentheses, I have to understand that 1/3 is being multiplied times that. So I'm going to take 1/3 times x squared, which gives me the 1/3 x squared, 1/3 times 3x, which gives me the x. 1/3 times 9 over 4 is actually going to give me 9 over 12, right? 1 times 9, 3 times 4. So 9 over 12 is what I need to write right here, so that I make sure that when I subtract 9 over 12, if I distribute this and subtract that, that I'll get the original equation. It'll cancel this term out. Then obviously 1/3 times 1 would give me the You know, I made a mistake here. I didn't even notice it. 1/3 times 3, I didn't check my answer earlier. Sorry for this mistake here. 1/3 times 1 is actually going to give 1/3, not 3. This should have been a 9 right here. So sorry about that. That should be a 9, which means that this would be 9. Okay, just a little mistake there. 1/3 times 9 would give me the 3 there. So now that we've got that fixed, let's keep going. I need to take this here and then factor it down. So f of x plus 9 over 12 equals 1/3. And then remember, I do the brackets, and I'm going to put in here my two binomials that I'm breaking that into. So I need something that adds to being 3, but then multiplies to being 9 over 4. Well, I know 3 over 2. When I squared it, it gave me 9 over 4. So obviously 3 over 2 plus 3 over 2, that's 1.5 plus 1.5 would give me the 3. So I need to have in here x plus 3 over 2 and x plus 3 over 2. Bracket. So then after that, I'll have f of x plus 9 over 12 equals, this will give you x plus 3/2 squared. So that's 1/3 x plus 3/2 squared plus 9. And now I need to distribute the 1/3 to each of these terms. So that's going to give f of x plus 9 over 12 equals 1/3 x plus 3/2 squared And 1/3 times 9, this was the mistake I made earlier, 1/3 times 9 should give me that 3 there, and that's what it does. After that, then I'm going to subtract that over. So I'll get f of x equals 1/3 x plus 3/2 squared plus 3 minus the 9/12 that I just subtracted from this side. So then what I want to do is common denominator for 3, and then this 3/1 and this 12 will be 36/12. So f of x equals 1/3 x plus 3/2 squared plus 36/12 minus 9/12. So f of x equals 1/3 x plus 3/2 squared plus 36 minus 9 is 27/12. So now I've got this in vertex form. I should reduce this. I'm not going to reduce this just because I'm running out of time in the video. But you should reduce this. When you actually write the vertex, I'll write that as the reduced version of that. So the vertex then is, again, you look at what's 3/2 here. How did that get in there? Well, that's negative h. Oh, you can't see it up there, but remember, negative h. Okay, so if you've got 3/2 here, that's actually negative 3/2. The other way to think about this is what can I plug in for x to cancel that out? That would be the negative version of that. And then this, I'm going to reduce this from 27/12. Okay, that can be reduced to divide by 3 on each of those. That'd be 9/4. So that's going to be 9/4. And that's converting from standard to vertex form.